Today we are learning how to make predictions. This is Chapter 7, Section 6. Our goal is to be able to predict the actions of a larger group by using a sample. A survey will be taken of a large group, and the surveys study a population. And so population is just a large group of people. So maybe an example of a population might be a school, a state, a nation. And it's not always practical to maybe take data from the entire school or the entire state or the entire nation. Could you imagine asking every single person in the nation what they thought about something? So instead of using the entire population, we take a part of the group. A part of the group is called a sample. Okay, so when we're doing surveys, we're going to look at what makes a good sample and how to predict what the entire population might do given the results of that sample's survey. So what are some characteristics of taking a good sample? Well, good samples are random, which means that the odds of choosing one person are the same as another. Okay, that's a good characteristic of a good sample. The other one is that your sample represents the population. So if you're taking a sample of the schools, like if you're going to ask all the students in the school, you want to know what the student opinion is on something, and you just ask the boys their opinion, well, that's not going to be a good representation because a lot of time boys and girls have different opinions. Or sometimes if you ask the 6th graders their opinion could be different from the 8th graders. So you want to make sure that you're representing all the different demographics of your population. Okay? The other one is that it needs to be large enough to be accurate. If you ask one person a question and take their answer as the representation for the population, usually one person's ideas may not be the same as the entire population. You may get someone who's way off, on left field on some of their ideas. Okay, so those are some of the examples of good samples. A lot of times, samples will be taken and they'll be intentionally not really good samples, but they'll be made to represent a population, especially, in the political times right now when we're doing elections coming up and stuff like that, is, if you think about it, if we're doing a sample of people's outlook on the economy, and you call them in the middle of the day, in the middle of the week. Well, the people who answer the phone in the middle of the day, middle of the week are going to be either stay-at-home parents or unemployed people or self-employed people. So, bringing in that demographic versus the people who typically work outside of the home is going to give you a different representation than the actual population. Okay, so those are some of the things that happen when you skew your samples, when your samples aren't really representative of your population, or if they're not large enough to be accurate. Okay, so how can we use samples to make predictions? Well, predictions are made using proportions. Yes, we can't get rid of them. Proportions are back again. Okay, so if we look at this data table here, we see that it looks like it's a data table of activities that students like to do. So 15 students want to go to an amusement park, 10 want to go to a baseball game, 10 want to go to a water park, and 5 want to go to a museum. Okay, and let's say that this is a survey of my first period class. And I'm using this data to figure out where I should take my entire class. Okay, all of my students. So let's say I have 120 students, and I surveyed 15, 25, 35, 40 students. Okay, so 40 total. And I say, well, if I surveyed 40 students and I've got a total of 120, how many of my students are going to want to go to the art museum? Okay, well, if my total is 120 and my total surveyed was 40, so my total goes on the bottom, the part goes on top. So 5 out of 40 want to go to the art museum, so how many out of 120? Well, so how do I get from 40 to 120? I multiply by 3, right? 4 times 3 is 12, 40 times 3 is 120. So I'm also going to multiply the top by 3, and I'm going to get 15. So now I know 15 out of my 120 students will want to go to the art museum. Okay, let's look at another one. Okay, so we still had 40. This was first period. So if 15 out of 120 wanted to go to the art museum, how many don't want to go to the art museum? This is the probability of art. What's the probability of no art, not wanting to go to the art museum? Okay, well, now we're looking at that complement again. So the whole would be 120 out of 120. And the probability of the art was 15 out of 120, which means the probability of not wanting the art museum would be 105 out of 120. Okay, how accurate is this? I don't know. It depends on the type of people who are in my first period class. Maybe my first period class was all boys, and that's not really, my other two classes might be all girls, and maybe girls are more apt to want to go to the art museum, so that could throw my sample off. I may not have a good sample here. But if everything stayed the same, we would be looking at predicting 105 out of the 120 not wanting to go to the art museum. So let's look at the next example. Okay, this one is, now it's time for you to try. You're going to use the information in this table. Every 10th student entering the school was asked which one of the 4 subjects was his favorite. So somebody stood at the front door of the school, and every 10th person that came in, they were asked, what's your favorite subject? So we want to find the probability that any student attending school prefers science. So what is the probability of somebody preferring science? And the second part is going to say there's 400 students in the school. Based on this data, how many students would prefer science? And number 3, how many students would like language arts or social studies? Okay, so that's you try. Try these 3 and then come back and check it on the key. All right, let's go ahead and check. Okay, so the probability that any one student prefers science would be 15. 15 like science out of 10, 20, 30, 40. So 15 out of 40. And we can simplify this. We can divide both by 5, and we get 3/8. So 3 out of every 8 students prefer science. If we turned that into a percent, it would be, I think, 37.5%, or 0.375 as a decimal. Okay, number 2. There's 400 students in the school. Predict how many students would prefer science. So 15 out of 40 prefer science, and there's 400 in the school. So what do I multiply by 40 to get to 400? Times 100. Okay, so then I multiply my 15 times 100. I'm sorry, 10, my bad. Okay, then 15 times 10 gets me 150. So 150 out of the entire school population prefer science. Okay, the next one says, how many students would like language arts or social studies? Okay, well, 10 like language arts, 5 like social studies, and your total is 40. So again, look at that, we have 15 out of 40. And if we were looking at the whole school, that'd be 150 out of the 400. All right, go ahead and write yourself a summary and rate yourself. If you have any questions, be sure to write those down so that we can answer those in class tomorrow. Thank you.